Alrighty, so today we're looking at 5D, solving equations using backtracking. So this is a strategy of how we solve equations. So backtracking is using inverse operations. So if we go next, if we start looking at a flowchart, so these box things are flowcharts. So it shows the order of operations to perform on a variable to produce an expression. You can backtrack from a final expression to the starting variable using inverse operations. Backtracking is another strategy you can use to solve equations. So, the first step says to draw a flowchart to build the expression on the left side of the equation. So, this is your equation, 4x plus 5, which is obviously over here, and it equals 29, so whatever it equals, it goes underneath. Since the equation or expression is equivalent to 29, you can write it under. So that's what I've just said there. Okay. This whole top row up here, okay, you need to write what's happening to the x. So x is our variable, which is here. Okay, then to make it a 4x, that's when we had to times it by 4. And then to make it a 4x plus 5, you have to add 5 to the expression. So that's how you get that first lot. Alright, so number 2, on your flowchart, copy the extra boxes and arrows shown in this diagram. Okay, so you finish it off by doing this bottom row of boxes, and doing this, it's going to help you to find x. Okay, to find x, you want to know, well, what's going to go in this box? So we use inverse operations. So inverse means like the opposite. So the opposite to adding is subtracting, which means the opposite to subtracting is adding, opposite to multiplying is dividing, the opposite to dividing is times. So they're your inverse operations. So that's why there's a negative 5 here, okay, because if you look above it, we were adding 5, so then we need to minus 5. So our next one, if we've got times 4, okay, we want to do our inverse operation. So instead of times, we want to divide by 4. There you go. So then we use backtracking to fill in the missing values. Okay, so I'll bring up the next bit. So yeah, we have 29 and then we minus 5, which gives us 24. 24 divided by 4 gives us 6. Let's see if that pops up. Perfect. So, therefore, what is the value of x after backtracking from 29? Okay, so we've started at 29, we're backtracking, which means x equals 6. Okay, so the solution for 4x plus 5 equals 29, x equals, 6. There we go. How can you check if that solution is correct? Well, you can substitute it into the initial value. So I'll just try to find an eraser. Okay, substitute 6 into the equation, and then you should get a true statement. Alrighty. This flowchart shows how to solve an equation by backtracking. So let's have a look at the first one. What is the variable in the equation? So we're looking at this. What is the variable? Okay, variable meaning what's the letter? Should be K. What is the equation that is being solved? Okay, so what equation? It should be this bit. K over 2 minus 1 equals 7. That's your equation. And what is the solution to the equation? Well, the solution is the number underneath your variable, which is 16 here. That tells you what your solution is. Alright, and how can you use backtracking to find the solution? Okay, how? We work backwards using inverse operations. That's your key point there. Working backwards using inverse operations. Alright, so just to quickly summarise that, an equation can be solved by drawing a flowchart and backtracking. Backtracking is using inverse operations to work backwards from the final expression to the variable. And you can check if a solution is correct by substituting the value for the pronumeral into the equation and seeing whether it makes the equation a true statement. Alright, let's do some examples quickly. This one, so we're completing a flowchart to solve an equation. Okay, so let's go back here. Write the equation to be solved and its solution. So look up here. We have x. Okay, what's going to go in the next box? We need to write x minus 4. Okay, because you start with an x and then it says we need to subtract 4. So we write that in the box. Then we need to do x minus 4 divided by 3. Okay, so x minus 4. So at the moment we're just building the expression. We're not solving anything yet. And what this flowchart is telling us is that x minus 4 over 3 equals 2 because the 2 is underneath here. Okay, then what we do is go backwards. So it's already written the inverse operations here. So because there was a divide 3 up the top, we times 3. So 2 times 3 is 6. And then because there's a minus 4 up the top, we go plus 4. And then 6 plus 4 is 10. Okay, that means the solution to the equation, so you've got x minus 4 over 3 equals 2. By using backtracking, we found that x equals 10. All right, let's check it by substituting x equals 10. So we're going to write this equation, but instead of the x, we put a 10. So we've got 10 minus 4 over 3 equals 2. 10 minus 4 is 6. 6 over 3 equals 2. Okay, that means it's true. So that means we got our equation by backtracking or using our flowchart. If I hit next here, it'll have all of those steps that I've just done in red. And I'll just bring up my rubber. Okay, and it's got the x minus 10 there, so that's correct. All right, so let's start from scratch. Here it says to solve 5x plus 6 equals 20 using backtracking. So let's set up our boxes. So I'm sure you can all just hear my cat meow then. All right, we're going to start with our pronumeral in the box, which is x. Okay, then I'm going to say, well, what's happening to my x? Am I adding 6 or am I timesing by 5? Because this 5 is outside the brackets, the 5 says it wants to multiply everything inside the bracket. So we need to add the 6 first. So we're going to plus 6. Okay, and then we times 5. It's important to know the order here because that helps you solve your equation. All right, so once you do that, you end up with 5x plus 6. All right, and it equals 20, so the 20 goes underneath. All right, so in order to solve, we use our inverse operations. So instead of times 5, we're going to divide by 5. 20 divided by 5 is 4. And then instead of plus 6, we're going to minus 6. So 4 minus 6 is negative 2. Therefore, x equals negative 2. All right, let's check it. Let's sub in x equals minus 2 and see if we got the right answer. So you've got 5 minus 2 plus 6 equals 20. Minus 2 plus 6 equals 4. And 5 times 4 is 20. Okay, so that's true. So that's our answer there. All right, now you can pause it if you're writing notes. Otherwise, I'm going to get rid of this and check our answers. All right. X minus 2, fantastic, that's what we got. All right, go ahead and enjoy the chapter.